student can do pH just like that. You got to get to that point. So you got to be able to interchange to convert between pH and POH, H plus and OH negative, back and forth. Given one of those things, get the other three at any given time. You should be able to calculate the concentration of the hydrogen ion from a weak acid, just like that. They're all pretty much the same. We've got a couple on the board we can go over. So you just need to get to that point. If you get to that point, not only will you do well on the upcoming, test and quiz and stuff, but you'll do well on the next chapter. And you'll do well on the chapter after that. And then you'll do well on the tests that go with those chapters. And then you'll do weller. You'll do weller on the AP test too. If you haven't purchased your AP test, Mrs. Lane wanted me to mention to you that the deadline is March 24th, which is coming up real soon, like 2 weeks. Because they have to order them, and that takes time. I've never understood why it takes time. I mean, you can order a lawn chair through Costco, just like that, and get it in 2 or 3 days, but it takes a month to get an AP test. I never understood that. But the state is involved.
Yeah, well, school, like, August half month.
Anyway, school is involved. It's a bureaucracy. All right, so any questions on 47 or 48? I'd be glad to give you answers. Look if I can find them. Here they are. 48, 1. pH is 1. Then you're going to stop me if you need any help or anything, right? 49, 53, 8, 54.
53.
Back to 49.
47.
Yeah.
48.
I didn't know you had to do 49.
Yeah, we do. You just had 49.
Oh, you know what? Okay, see if this will help. Remember yesterday how we talked about when you add 2 weak acids together, you ignore the one that has the real tiny little Ka and just key on the other one? When you have 2 strong acids, you can't ignore them. That's like 2 lions in the same cage. They're hard to ignore, okay? So you have to account for both of them. But strong acids are easier because whatever the concentration is, that is the H plus concentration. So you just add them up.
Wait, what?
So you just add them up.
I wanna.
So looking at 49 then, a solution is prepared by adding 50 milliliters of 0.050 molar HCl. Okay, let's just turn that into moles. 50 milliliters, 0.050 molar. Let's see, moles is equal to molarity times volume. So what's 50? Well, this has got to be in liters. So this is 0.0500 liters. So what's 0.05 times 0.05? I never know how many O's. I can't do it in my head. So 0.00? Yeah. Why is that? Oh. Well, I knew that, but I didn't know how many to add. Yeah, how come why didn't we add another 0? Is there a shortcut to that? Like Leo the lion goes roll?
No, you add up how many decimals.
I think you add up how many zeros in front of the decimal.
It was
So,
You add up all the decimal places.
2 zeros, so 2 zeros?
No, you add up all the decimal places.
Yeah, I'm afraid.
There's 1 0 after the decimal place before
Okay,
any number.
so this is
And that
HCl.
one and the one above. So,
What was that?
You
see how there's a
the-
0 at the top number or the third number, there's a 0 right there, and there's a 0 right there, so that's 2. So
It's not.
2.
Yeah,
I can do it.
Anyway, back to this, sorry. I'll just keep using my calculator until you guys get it all figured out. 150 milliliters of 0.10 molar HNO3. Well, that's like 0.1500 liters. So 0.1 times 0.15 is 0.015. That's good. Moles, HNO3. Okay? If I add those up, see, these are strong acids, so this is going to completely dissociate into 0.0025 moles of H plus, 0.015 moles of H plus. So all I do is add them up, and that's how much H plus I got. 0.0175 moles. and then divide them by the total volume.
Which is 200.
0.200 liters, and if they asked for the molarity, then I'm in good shape. If they didn't, then I'm not done yet. So, because I didn't read the whole question, I got all off on that. Does that make sense to you? Just kind of common sense. This is for strong acids only. Weak acids, you don't do that. So 0.0875 molar, and that's the concentration of the hydrogen ion. So if we want to know the pH, we don't have to know that?
The concentrations of all species in the solution.
So all the species? Okay.
That's fine one.
What was it? 0.0875 moles per liter? If you want to round that off, it's 0.0888. 0.088, those of you that like future accountants, you know. Okay, so anything else you want to know? All the species. Calculate the concentration of all species. Well, what's left besides the H plus? We didn't show the dissociation of these, but HCl is going to break up into H plus Cl minus. Well, isn't the chlorine going to have the same concentration?
Well, it has a point of
Yes, thank you. It would be 0.0025 mole. Yeah, let me slow down a little bit. Let me get the other dissociation. The HNO3 is going to be H plus NO3 negative. Now we just covered the H plus, so this is equal to the concentration of the H plus, okay? The other two are not this concentration because there wasn't two of them to combine. There was this one at 0.0025 moles. So for the concentration of the Cl, it's 0.0025 moles divided by the total volume, 0.200 liters, because they're combined. Concentration is going to go down because we added it to a second solution, whatever that is. And then the concentration of the NO3 negative, which is the other species, is going to be 0.015 moles divided by the same amount, 0.200 liters. And I have those answers written down. So you probably know the answers to those. So let's see, the chlorine comes out to be 0.013 chloride, and the nitrate comes out to be 0.075 moles per liter. So what have we done here? We've added two strong acids together, and they've asked us to figure out the concentrations of everybody. H plus, CO minus, NO3 minus. The H pluses are the sum of the two number of moles divided by the total volume. That's the concentration. The other ones, it's the sum. It's not the sum, it's just their original concentration divided by the total volume. And that's, they didn't ask for pH or anything, but that's how you do it. Okay. What would the pH be of that? What do I have to do in order to find out the pH? Which of those do I want? This one?
Yeah.
Negative log that? Wonder what it is. Think it's big?
It's a negative sauce.
It's a number, thank you, yeah. It's 1.1 pH, pretty low pH. All right, so that